So I began kind of my career as a software developer. So I started programming at the ripe young age of 10 and worked my way up from Pascal and Fortran to C and Java and .NET. And I worked for software development companies for a number of years doing everything from device drivers to thick client applications to some web apps. And then along the way, I had an opportunity to do, one of my projects was data mining software where we were writing code to do anomaly analysis on network traffic. And that, prior to that, security was sort of a hobby and just an interest, and I was like, hey, this is kind of a potential profession. And that was back in 2002, so it was quite a long time ago. So I transitioned from software development into InfoSec, and I began red teaming, pen testing, and did a lot of work. At the time, I was at Sandia National Laboratories. But then I transitioned. I also got my master's and focused on information security and information assurance. And then I transitioned, and I went back towards application security and software security. So prior to this role, I spent 5 years at Fortify Software during the startup days, and then also post-acquisition after we were acquired by HP. And so I spent those years, all of them in services, working with companies, implementing both static analysis, but also helping them figure out how to be successful at software security, how to engage their development teams and make improvements that were tangible, but to do it in a way that was either cost-effective, either politically or financially, politically in business sense, or meet their compliance goals, just integrate technologies the right way, and so forth. So in that time, I'd spent a lot of time training developers on secure coding because you can't fix it if you don't know it, and we'll get into some of that further. But as well as teaching the managers and helping them establish programs that could be successful and sustainable on their own. So they didn't have to have consultants in all the time to do things, that they could do it sustainably, or they could take a small security team with hundreds of development teams and actually get that to scale, and not have to have each team come to the security team to do things, to empower those development teams to do things on their own and have results. And then my current role, I'm a security architect at Service Mesh, so there's a little bit of a change in that we have one development team, one product, and I'm part of that development team. So rather than being the consultant, product security is a function of our development team, and so there's lessons that I learned from that, and I wanted to share some of those as well. So the goal today is really to help you, pick up some of these attributes that you can take with you and implement with your own teams. Now to do that, I want to do a little bit of scoping, and those of you who are familiar with the development process, scoping is very important, and it's as important to rule out what you're not doing as it is what you are doing. So I thought I would try my hand at that as well. And this is not to say there's anything bad about the things I've ruled out. It's just not something I can cover or the primary focus of today's talk. So compliance and triage and incident response are very, very important for programs. But these are live kind of exercises. It's not something they're generally reactive, right? Because you're going to have either you failed an audit or you've got a compliance activity going. As a business, you have to do that. There's no choice, and you have to do whatever you need to do to get through that audit. Likewise, with an incident, you need to do what you have to get through the incident, to get your response going, to do your forensics. It's not necessarily a proactive enterprise. You can do things in advance to be prepared for that event, but when you're in the midst of it, none of these tips are going to help you when you're in the midst of those activities. And one of the keys that's important to me is not punishing development teams, right? And we'll get to why that's the case shortly. And despite my caveat that I was at a vendor before, this talk is not about tools that you can buy. I may mention some by name, but there's no endorsement involved there. And in truth, there's no tool that you can buy that's going to solve these problems. This is as much about the people and the process challenges as it is about any particular technology that you can implement. But some of the things that I do want to try to help you achieve are proactive, iterative improvement strategies. Things, for the most part, looking back at them, they're very little things, but they're things that will help you structure your program to be more effective and to have demonstratable results over time. Empowering the development teams to do that and to have repeatability in doing that. And as a result, ending up with better software. Right? And you may never get to a place where it's completely bulletproof, the software and applications that you're building, but you can get them to be better and better. And like with everything else in security, you don't have to outrun the bear, you just have to outrun the guy next to you. Right? And so there is a trade-off, and part of that is making your software better than your competitors or those others that you may be competing against. And finally, to whatever tools you decide to use in your process, to do a few things that you can try to use them more effectively and to get the best value out of using them. So those are the goals. Please feel free to ask questions during. There's also some time at the end, and I'm here for the whole day, so you can also ping me afterwards. I'll be here all day tomorrow as well. And I'm local in Austin, so if you happen to be local in the region, feel free to contact me and just chat or go to a happy hour. So there's 5 core success strategies that I'm going to talk about and go through, and I'll also highlight some case studies without naming names of things that were successful and why, and less successful and also why. So we'll start out with developer education and learning, a roadmap, integrating to your SDLCs and your team's SDLCs, using tools effectively, and then lessons learned from joining the development team. All right, so first up is developer education. So just by a raise of hands, how many of you have taken computer science courses? All right, that's more than I expected. How many of you remember, let's say, your first 4, we'll call it your first 4 computer science courses? A project that you did, some of the things that the teacher made you do. And through those first 4 courses, how many of you ever heard the word security discussed in those courses? So this is a major challenge. Right? And as developers, in those first 4 courses, you're learning the core of the language. Generally, you're learning your fundamental data structures and algorithms. You're running object-oriented programming. And depending on the nature of your curriculum, by that point, you've already built several functional applications. Now, let's say it's sometime later, and you're going back and you're like, hey, I remember doing something like this in my course. How would you reuse that design pattern that you learned? Well, you'd probably go dig up your code, copy it, paste it, and use it. And there's nothing wrong with that, right? This is how we get things done in the world. And whether that's a developer or whether it's an accountant with a spreadsheet, it's the same thing, right? We're going to reuse things that we've already done. But the challenge is that our developers haven't been taught and integrated into their education the ideas of security and software security, and even down to the basic design patterns that they use. And so in that sense, you can't blame someone for not doing something that they were never taught to do. Right? So it's kind of like being angry at your 12-year-old for not knowing how to drive the car. Well, they haven't gone to driver's ed yet. Right? They haven't learned any of the fundamentals. And this is still the case. So every so often I do a review of top curriculums in computer science. So just this week I was looking at, in preparation for the talk, I was looking at curriculums from MIT, Carnegie Mellon, UT, and Stanford, which are fairly good education programs. They have a strong focus in engineering. They've integrated kind of engineering concepts into their computer science courses. But when you look at the curriculums, the books they use, there's, and then the courses and topics they have computer network security almost always as a junior, senior level course. And most of them now made it mandatory. A few years ago, it was still just an option, an elective. So now there's at least a mandatory subject of that. But that's all after you've learned your design patterns. And so now going back and recorrecting those is pretty difficult. Likewise, you can still pick up, and I happened to skim one a couple months ago, you can pick up brand new edition, current edition, database programming books, web programming books. And the first half to 2/3 of these books will show you how to build functional applications that work with databases, that help you build websites. And then you get to the back, and that's where you have things about performance and security. And so it's not a surprise when you've got new and young developers coming out, and they don't know the design patterns that we want them to be using. Right? And so it's not a surprise that cross-site scripting and SQL injection for the last 10 years remain the top 2 issues in web application security. And for neither one, for both, they're incredibly solvable design patterns. They're incredibly well understood and researched design patterns. They're not, a new floating point 0 day in the JRE, right? Which happens now and then, but this is not, something that's extraordinary rocket science. But we have to kind of build that back in to our organizations. So for those of you that have development teams, and this will kind of demonstrate the bullet point, how many of you invest more than a day a year in developer education? Not including conferences.
Say again?
How many of you invest in your developers? How many of you send them to get training, technical training, not at a conference, for more than a day per year? It's just a handful. And that's a big deal. Right? I mean, think of any profession, even for us, those of you that have CISSPs or CSLPs or other certifications, right? What's the credit hour requirement that you're supposed to do annually for your certification? It's 30, I think. Something like that, right? And we don't have the same structures for developers. And for the most part, companies treat developers as a commodity, right? Rather than sending a developer to a course to learn about high-performance algorithms, they'll just hire someone who's taken a class in high-performance algorithms, or they'll look for someone that has it on their resume and has done it already. But that doesn't necessarily help you scale and build the resources that you have available. And also, often training can be a checkbox. And that can be okay in some circumstances. If you've got a compliance requirement that you must have security awareness training for all developers, well, by golly, you better check the box. But that doesn't mean that training will necessarily teach them everything that you need to teach them. And so there's a challenge to that. There's lots of different ways to do training, not all of which cost a lot of money. Some can, others, but there's various formats. But what's also important to recognize is the ability for those developers to retain what they're learning. How many of you have taken those kind of corporate ethics CBTs that large companies always have to do? I see a few chuckles, right? How much do you actually remember from those besides the badly acted videos that come from them, right? Very little. And that's still the case, I'd say, for the majority of software awareness, security awareness trainings that are out there, right? It's check the box training to make sure, okay, every employee has received this, but what is the developer taken away from it that's actionable? When you get to more specific ones, often, and there's a great set of courses that are out there from various vendors on secure coding. And they even have secure coding for Java or secure coding for .NET and the various languages. And they're definitely a big improvement over generic awareness. And they're a big improvement over kind of the attack-centric courses. There's a lot of attack-centric courses that teach you how to break web applications, not as many about how to build secure ones. So there's a spectrum there, but even those courses teach a developer in a very generic design pattern way. So if you're a developer and you're being taught about inline SQL, and they teach you about how to use parameterized queries, and that's really helpful, except if your development stack is all with Hibernate, you never touch that. And so while you've learned something, your ability to apply that in your own application is now taken away because it didn't teach you something that was about your development stack. And that makes it very difficult to retain. Right? So because you never now practice it, some years ago, it's going to be difficult for you to retain that. So one of the mechanisms that's been really successful in my career in balancing that is using the workshops, using those courses, but using the developer's own application as the subject for the course. Now, if you're getting a vendor to do it, that can cost a little bit more because the vendor probably has to scan or analyze your source code or to find some examples in it. But it can be very helpful. If you can do it internally, you've got a senior resource, or you can partner with a senior architect to do that. That's even better. And it doesn't have to be kind of an expensive all-day endeavor. One of the best things you can do is to do it with lunch and learns. And developers love free pizza, so you have pizza, or in the case of our office, everybody loves Fireball, which is a local stir-fry place. So we bring in food, and then we have a topic about 1 or 2 design patterns. We keep it simple, we keep it focused, but we're looking at our own code. And so we're looking at our own flaws in some cases. There's usually some humor associated to it because there's some ribbing about who wrote the code and when they wrote it and how many happy hour beers they had. But it keeps it a little bit lively, but it's also relevant. So everything that we talk about now is directly applicable to new code in our application stack. However complex or simple it may be, it's directly actionable. And that makes a big difference. So just an example of how this has gone in the past with 2 different companies that I worked with. And with each of these case studies, I'm obviously trying to anonymize a little bit. There's many variables. There's no one variable that defines everything. But I tried to pick things that were as similar as possible in terms of all the other process and performance variables of the 2 companies to make it fair. So in the case of the first company, they had a mandatory computer-based kind of awareness training. It was very focused on awareness. There was no code-level examples in that training. So everybody took that. And then 1 developer per team was designated to receive more technical training. But that training was focused on a generic web application. In that case, I believe it was actually WebGoat, so the OWASP WebGoat project. And we actually looked at down-to-code level analysis, but of WebGoat, right? So just looking at the WebGoat technology stack, not what they were building themselves. With the other organization, everybody got technical training. And that technical training was primarily from their own code, but with a little mixture of WebGoat baked in. So where examples couldn't be found in their own code, we use WebGoat instead for those examples to blend it. But there was a specific focus, right? Rather than spending time on the entire OWASP Top 10 or the entire set of findings that we could get, there was a specific focus in taking the top findings in their application and talking about how to remediate those particular findings and walking them through in design detail, talking to them and really engaging in a discussion with the whole team about the background of that particular code, the requirements, the performance needs, and then saying, okay, how could we change this? And what would you have to do to do that? And so they came out of that essentially with a plan of what they would do to fix those issues. Now, that second team was part of a pilot, and it was actually 3 different development teams. So we did a pilot with them, and I wouldn't say a contract, but there was a commitment with each of those 3 development teams that in exchange for receiving this training and for the company making that investment in them, they would have to commit to fixing 20 issues in their application. Right? And it was a reasonable request. Initially, the ask was 50, and they complained about that. And so it negotiated down to 20, and so they all committed to 20 things. And they had choice, right? It wasn't the security team or us as the consultant telling them which ones. They had input into which ones they wanted to fix. And they had a month to do it. So it was pretty reasonable. So from the results of that, kind of comparing the two, in that first group, that first organization, the development teams kind of continued as normal. Nothing really changed for them. They had their awareness training, but very few issues got fixed because there was nothing tangible about their application that they could go and change. But they did learn some things, and there were some things that got fixed, but it wasn't broad. But the biggest thing was that from there forward, they still relied on the security team to tell them what they had to do. Right? And they didn't have the insight about their own code to sort of say, this is more important than others, and so forth. And so they had a big list of findings, but they relied on someone else to tell them what was more important. In the second team, and this was, as I said, this was 3 different development teams, each asked to fix 20 issues. Right? So the expectation was in a month, 60 issues. And this is a month of developer time. The actual results was just shy of 600 issues, like 590-something issues fixed. And in a sum total from the 3 teams in 10 development days. So they had a month, essentially, for one person per team. They had 30 days available to them to fix the 20 issues. And across the 3 teams, they only actually used 10 days total. And that was skewed even because 2 of the teams only used 2 days each and the one used more. But they fixed almost 600 issues. And the reason was they had a plan, right? So, and they actually fixed it within about 10 days of the course because once they came out of the training course, they knew exactly what to do. It was in the terminology that they needed. It was in the exact architecture that they needed, and they just went to do it. And from there forward, they were able to recognize things about their application. And so in the next, I didn't have follow-up years later with them, but in the next 2 months during the course of our pilot, they would come back and contact us and say, hey, we found this other thing, or we think this is an issue. Can you give us some advice? Or they would just go fix them. And so they started to reapply those new patterns right away to all the new code that we're building during their new development cycles. So there was a big difference, and the cost investment between the two for the training was about the same. Right? Because they were still sending them all to training. They were paying per person. The biggest difference was with the pilot, they spent a little bit more time on our consultant up front to learn about their application, and they trained in that particular application. So, yeah, sure, there was a little difference, but we're not talking hundreds of thousands. We're talking like $5,000 or $10,000 difference, which isn't very much for a pretty significant set of results. So with that, some tips that you can take with you about approaching training in your own software security program. So you've got to have management buy-in, right? There's no way that you're going to get the approval to train every developer without some sort of management buy-in. And that could mean the dev management, it could mean business management, but somebody at that level has to say, this is important. But the value that you can take to them is to say, this will make your developers better and faster, and it will reduce the time that it takes to remediate things. And that's enough of a carrot to fix things. Another carrot to kind of bring into that is to commit to follow-up actions, right? So you're giving the developers training, you're helping build their skills. It's fair as part of that bargain to say we expect an X amount of commitment afterwards that you're going to apply what you learned. And that helps a lot, both in terms of their ability to retain that and reuse it, and also to demonstrate the value that you're getting for whatever dollars you spend on that training, whether it's time internally or a vendor that you bring in. The vendors can certainly help, but again, you have to choose wisely. Some of the vendors use, for training, they use an instructor, but that's a teacher, not a developer, right? So it's not someone who necessarily is familiar with the development or the specifics of content. They're someone who's trained and skilled at teaching a class. And so there's a trade-off there. And often, it's a double-edged sword. It can go really effectively if you take like a senior architect who knows your application and you have them teach it. But it can go the other way too if they're, if it becomes kind of antagonistic or if they're not a good communicator in front of a room of other peers. So that's something to keep in mind. And you almost really have to assess who you have available on your team, who's skilled enough to do it, who has the credibility and the kind of management of a room to do it, or if you need to bring someone else in. Definitely use their own applications, and that I found is the most productive thing to help retention and also reuse of whatever they learned. And then finally, development organizations are very fluid. So developers move teams, they change companies even. So you've got to have some refreshers built in on a reasonable basis. And those refreshers don't have to be a full-blown class. It could just be a lunch and learn on a specific topic. Doing that once a month or at least once a quarter is a great way to keep things in touch. And also gives you an opportunity to bring in things that are happening in the marketplace. So one of the things I do whenever I do a lunch and learn at our company is I save the last 5 to 10 minutes and I talk about things that are happening today, right? So either new breaches or new flaws that have been reported, and just to kind of keep people apprised of new things that are happening out there. And so that could be, sometimes it's even just a new dev framework that seems really interesting that we might like, but that keeps it engaging and forward going. So the next kind of core area is a software security roadmap. And this is an example of a roadmap. And it's very similar to ones that I've used in the past. And what this does is it lays out your priorities for what you want to have addressed. Now you notice I didn't have the entire OWASP top 10 in year 1, right? Which is what your compliance auditor will tell you have to do. Because for the large part, that's not achievable. So one of the key things about this roadmap is that it has to be achievable. If the OWASP top 10 for your application, and for most applications, that's thousands of issues, to fix that many issues is going to fully derail your business, right? and whatever that application or product is. So you can't do that. It's got to be some measure of things that are achievable, but also justifiable from a security perspective, and forward-looking. But there's other reasons why this is relevant. And I happen to pick year, and that goes pretty well for very large companies. If you have a very small development team or a very agile process, you could set it up for quarters, months. Just depends on what kind of commitment you have to execute on those things. And if you change the cycle time, you could also change the items that you put in each cycle to match that. But one of the key things about this is it's forward-looking. So a good development team, and most development teams are very good, will have a complete backlog, right, of probably 1 to 2 years' work of all the new feature requests, defects that they have to build. And so by having this planned out some years in advance, maybe with an asterisk that says subject to change, based on new vulnerabilities that are exposed or whatnot, what this has now done is given them a new set of requirements that they can fold into their development cycle. And that now is plannable work rather than being a new requirement brought in, pre-release, post-QA that has to be emergency fix. And so by doing that, it's an opportunity. Now, not all development teams will take that opportunity, but your good project managers, your good development teams will take the opportunity and say, okay, when can we cycle this work in? When can we plan it? And that's going to be a fluid conversation, right? And like with any other feature, they may plan it in, but then ultimately move it out. But what that roadmap does again, is making it a plan requirement, but also communicating these priorities to the company. It's also very valuable for the business sponsors because now they know they've got to incorporate those in. Or if there's something in that list that a business sponsor says, no, this is more important, now you've got a sponsor who says, we're gonna do this, and now they're responsible for helping you fund it or make it a priority in the development organization. And then the other key is that it can reduce that untimely blocker. Right? Instead of security being the group of no, it's really saying, here's what we want of you. Here's what we're asking. Here's the time frame going forward. And it's up to you on how to do it. Right? And we're here to help. And then finally, with any development process, and most teams already have this in place, they're tracking how long it takes them to implement requirements, how long it takes them, how long things are in the backlog. And so now you can pull those measurements from their own development tools. So an example of that, I had two organizations. The first one, we sat down and talked about what are the key problems that you have. And they looked kind of backwards through their incidents and previous compliance audits and so forth. And they said, look, 80% of the issues that we have that we get dinged for are cross-site scripting and SQL injection. And so, bam, that was number 1 and 2. And we just picked something else that was pretty reasonable. I think for that one we picked race conditions or something that they thought would help out with performance as well. And then they took a rough draft at future years, and they said, this is a rough draft, but this is what we expect that we're going to prioritize for the next forward years. And they aligned their training to the priorities. So when we did training for them, all of the training, 80% of the training was focused on the year 1 priorities. So we focused on SQL injection, cross-site scripting, and race conditions. And that's what we spent the time on, and digging into different development stacks and different application architectures that they used. In the second organization, they actively avoided prioritizing. They said, there's too many issues. We have the OWASP top 10, and we can't make a choice because we don't want to deprioritize something and have it slip. And there was good reasons for that in terms of their business and politics. So what they did was they crafted a metric. And what they decided was they would take the software, the results that came from the static analysis software, they would take those priorities, which were kind of high, medium, low, and they weighted them on a log scale. So, kind of 10 for a high, 1 for a medium, and 0.1 for a low. And then they essentially created a density metric. And they kind of added up all of those scores for all the issues and then divided by the number of thousands of lines of code. And so it became a density metric based on the weighing. And then they drew an arbitrary kind of line as to what was a pass and what was a fail based on that density. So the result was, for the two organizations, the first organization that drew out the roadmap, they had a big drop in their key issues. Right? The ones they prioritized, they saw a big drop for. Now the other issues didn't get fixed right away, but some of the development teams that either had already fixed their cross-site scripting and SQL injection issues before, they took that time and opportunity to start working on future issues, just to be ahead of the curve, and so that they would have some release stability in the future. Right? They weren't doing it for security, they were doing it for their own purposes, which was to have release stability and to make sure when we give a target date for when we're shipped, we're going to ship it because security's not going to come knocking. And they trained the developers on those priorities. The second organization, the development teams learned to game the system. So they figured out that the scoring was weighted in a certain way. And so they would fix just enough of the high issues to get below the line, whatever the density line was. Ultimately then, the process itself failed an internal audit because they said, you're still going to have high issues and you have no assurance that people are going to fix them because everything is based on this metric that everybody can gain. And there was no real, there were other reasons they failed the audit as well, but that was one of the key ones, is that that metric is there. And it was also possible to inflate the metric by keeping your dead code around, because it added to your lines of code count, which they also didn't happen. But the organization was stuck as well, and this is kind of a different challenge, in that they had spent so much political capital behind that metric to say this is our solution, so that security sponsor really didn't have any political capital left to the business to go change it. And so hopefully by talking about that example, that's a lesson that you can avoid and not repeat, because it ultimately didn't lead to big improvements in their applications. It just led to a lot of paperwork being shuffled all around and lots of checkboxes being checked, but no real reduction in risk. So that some of the key tips, I think I've mentioned most of these, but you've got to have buy-in for management on what the roadmap is. Another key is that one roadmap isn't likely to fit all teams. And so you may have to have multiple roadmaps, one for middleware type applications, one for front-end web-facing applications, one for PCI type applications, because there are some different priorities and different risk profiles. Or another way to approach it is to have one roadmap, but to have flexibility in negotiating or change the time periods, right? And so you could say, PCI applications must be, at this point, but the middleware applications, you can be kind of 1 year behind, or 6 months, or whatever the cycle time is. So in having those negotiations is a good thing, because what it does is it engages the development and architecture teams with you, and you can talk about the pros and cons. And having that discussion, now is going to improve the roadmap, but it'll also improve the relationships that you have with them, rather than kind of being dictatorial about it. And this is really, I think, one of the biggest keys is the roadmap should then drive your investments in training and also tools. Right? So if you decide to go purchase tools or purchase training, now you have a map of, we want training that does this. Right? Rather than having the vendors come to you with a menu of, here's the training options you have, which one would you like? You're now proactive in your requirements of purchasing and saying, this is what we want. And you're also more able to measure, does course A or course B better fit what we want to teach? Right? And you can run a pilot and have a very clear criteria of success of which one is better. The next step is really integrating into your SDLCs. And we're a little short on time, so I'll go a little faster here. But most often, and often today, I know it's getting better over the last few years, but software security can still be sometimes an ex post facto activity, right? It's towards the end of the release and development cycle. So we need it to be earlier. And there's lots of different types of methodologies. But the key is to kind of empower the development teams to have security be integrated into what they do. And there's no shortage of activities, right? So this is largely waterfall, but essentially you have the same phases in Agile, in Scrum, and in other pieces. So there's lots of different activities that you can do during the SDLC. And the challenge is really to integrate them in to the process, right? So having that requirements discussion early on, which with a roadmap, now you have requirements that are clear. We want this, and here's the time frame that we want it in. Having design reviews and peer reviews and using tools or test cases, these are all important, but they can be integrated into the SDLC. The challenge with this and where companies have gone awry with them is when these things turn into checkboxes, right? Where your security process is, and it's not the best use of words, but essentially it becomes, you become process servers saying, have you done this? Yes, no. Have you done this? Yes, no. And now that takes it away from being a dialogue. and having these things. So in my current company, one of the things that we wanted initially when I came in was we wanted to have threat models for every release. But we realized that when we do dot releases that are just essentially bug fixes, there's no architectural change. And so it was a waste of time and effort to take senior architects or developers and sit down for a threat model for every other month for that release. It made no sense. So instead, we said, okay, we want to do threat models, but we're going to do them for every major release. And that became kind of a negotiation, but we got a commitment to do that. And so now we have a threat model for every major release. And occasionally, we let one go, right? So we happen to have a release recently that really didn't have, even though it was a major release, it turned out we had a lot of bugs in the previous major release, and most of it was bug fixes. And so there was no new designs or capabilities to evaluate. We said, okay, yes, this makes sense. Let's not do it now, and we'll invest in it later. And that you can't have that dialogue if all it is a checkbox, because you lose that nuance. And so having those discussions really drives the value. So some key tips on that, treating the security changes as requirements so that they're plannable and actionable. Negotiating is a good thing, and it evolves. The processes themselves evolve, and they don't change. So you can't ask a development team to just shift what they do. It's got to be iterative. So you're going to change one thing at a time over time. And more often than not, trying to integrate into the SDLC and really asking the question, how can we do this as part of what you're doing in the SDLC? That alone, just asking the question and having the dialogue, was as much of a win for the relationship from security and the development team as it was the result that we got out of it. And so keeping that dialogue engaged and going forward was a real value. All right. A couple of things on tools. There's lots of tools out there, and there aren't bad tools, but tools are like hammers. There's ballpoint hammers, there's regular hammers, there's rubber mallets, there's jackhammers. And you got to pick the right one for what you're doing, right? Otherwise you break stuff. And these tools are the same thing, are really the same way. It's knowing what you want to solve. And that's where that roadmap comes in and tells you this is what you want to address, and are we picking the right tools to address that? The reality is that amongst all these tools, our ability to find vulnerabilities far exceeds our ability to fix them. And so the focus shouldn't be on, what does this tool find? Is, how can this tool help us fix the things that we want fixed? And if there's this stuff that's left on the shelf, that's probably okay if you fix the stuff that's the most important. And so that's the real key there, is that the roadmap drives the selection and the criteria. And you also want to empower teams to integrate things into their SDLC to automate them. And then structure the usage of the tools around the roadmap and around the training. I think we're pretty short on time. So I do have a couple of slides left, but what I'll do is I'll share them online. They'll be on SlideShare for last time. I can go a little long? Okay. All right. So this was kind of a case study on the tools. We had two teams, both using static analysis. The first team, what they already had in place a quality-focused static analysis tool. So they had something already in place. They were using it on a almost daily basis. But because the corporate security team had adopted this security-centric static analysis tool, they were forced to add that to their SDLC and to integrate that in. And so they wasted time and energy to do something that had such a marginal set of new issues to be reported. Right? They were fixing on all the things that the company had said were priorities. Their quality-centric static analysis tool was already doing them, and they were already fixing them. And so what it turned into was just a waste of time and a reduction in the, the relationship between the security team and the development team. In this other case, it integrated in a tool to run every week. And what they did was they reconfigured all the results to match their roadmap. And then they measured against that roadmap every release. And so over time, the result was they got better with every release, but they did it in a way that was meaningful and aligned to the priorities. So some of the tips with buying and using tools, align to the roadmap and tune, don't be afraid to tune the settings and the results to fit your roadmap. And sometimes, whether it's consultants or auditors, they'll say, oh, no, you shouldn't do that. This is kind of a reference source. I call BS on that. Because what's more important is that you have your priorities that have been shared and communicated and that you can stick to it and follow through on that those are achievable. One of the things that's always talked about with all these tools are false positives and false negatives. And my advice generally on those is get over it. Right? None of these tools are perfect. They're going to find stuff that you don't like that doesn't make sense. Find the quickest way to ignore it and move on. And they're going to find stuff and they're going to miss stuff that you didn't realize. And so you have to have a plan. You have to have understood through your threat model and the other security activities, there might be a gap here. Let's make sure we address it with some other testing, some other approach. And by doing that, you can kind of focus the tool to make things actionable for your developers. And that's the best goal, is to really have that development cycle be quick. And the reason is, developers will write, tens to hundreds of lines of code a day. So if it's a week, 2 weeks, 3 weeks before they get feedback on code they've written, then that's long gone. And so now any effort to go fix that code is now also coming with an overhead of where was I at that point? What were we thinking? What were those requirements then? Whereas if you got that feedback within a day or a couple of days, that overhead is much less and the result is much quicker. And then the last set of lessons I've learned is from joining the development team and really being in charge yourself. And I think this is a great step, and I hope that OWASP as a community, and kind of speaking off of what Nick mentioned in his keynote, that we all incorporate that. And whether that's bringing developers into OWASP or us joining the development conferences and going there, but moving that security function to be a product feature, product requirement, and integrating into those goals. And there's things I learned from that were incredibly valuable. Prioritizing is a continuous balancing act. And so, there are things that I had on my roadmap that I wish would have been done several months ago, and they'll probably be done in 6 months from now. But that's okay, because we got there together. And we got there through a dialogue and said, yes, this feature is more important than what I was talking about, and let's have the bigger win for the product. Right? And that really brought us together as a group. It also improved our credibility. Right? Before I joined the development team, security was an external function, and so there was this kind of back and forth constantly. And once we had someone in the development team, now developers and QA engineers, almost on a daily basis, come see me. Hey, I saw this. Is this a concern? We never would have had that before we were embedded in the development team. So we have that kind of evolving organically. And even though our metrics for the backlog of things that were already scaled to be fixed before, that backlog hasn't shrunk as much as I wanted. The thing that has happened is we fixed more issues and averted them at the early design and scoping phases than I could ever count. And so to me, that's still the better win. Even though there's some issue that's been there for a while that hasn't gotten fixed, I'm much happier that new things that we're building are much stronger to begin with.